Today we're going to discuss on how to deal with negative signs in algebraic expressions. This will be a two-part video where the first part we will deal with numerical expressions, simply expressions that involve just purely numbers, no variables, and the second video will be dealing with algebra expressions involving variables. But before we go to that, we will first talk about these two terms that I will be constantly using in my explanation. The first term is the opposite. Opposite or opposites, if you have two, actually are pairs of numbers wherein they have the same magnitude but different signs. So like say for example, we take this square that represents positive 1. So this yellow square, there's only 1, so that's positive 1. But if you flip this, it becomes negative 1. So the orange side represents negative 1, but still having this one, just one square. So we only have one square, but one is yellow, so which is positive 1, and the other side represents negative 1. So we see that 1 and negative 1 here actually are opposites. Other examples of opposites are 2 and negative 2. 2 is the opposite of negative 2. Negative 2 is the opposite of positive 2. Manipulating terms within the expression, we come up with what we call equivalent expressions. These are expressions wherein if you compute for the value, they will give us the same amount. Okay. So let's first deal with the case on adding a negative number to any number here. So I have 5 plus negative 4. Using the algebra tiles, we are going to show what 5 plus negative 4 is equivalent to. So using algebra tiles, we have 5 yellow tiles representing positive 5 and 4 red tiles or orange tiles to represent negative 4. So this represents 5 plus negative 4. However, we know that a yellow tile and an orange tile make a 0 pair. So how many 0 pairs do we have? Okay, let's see. So we have, that's 1 that goes away, that's another 1, that's another 1, and 4. So as we make the 0 pairs, we see that we are taking away how many are yellow squares from the set of 5 squares. We took away 1, 2, 3, 4 yellow squares from the set of 5 yellow squares. So which means that 5 plus negative 4 is equivalent to 5 take away 4, or 5 minus 4. So let's try to examine the resulting expression. So we still have 5 as the first number, so 5 becomes our minuend, the first added here. And then from addition, we have subtraction. But what are we subtracting now? We are subtracting positive 4. And don't remember, positive 4 is the opposite of negative 4. So when you add a negative number to any number, it's just the same as subtracting the opposite of that negative number from the first number. Okay? So let's apply that to 7 plus negative 7. So our first number, first add-in is 7. So we have 7. Then that's going to be minus. And the opposite of negative 7 is positive 7. So 7 plus negative 7 is simply 7 minus 7. Let us show that this two expressions are equivalent using algebra tiles. Okay, so we have our representation of this expression of 7 plus negative 7. So we have 7 yellow tiles representing positive 7 and 7 orange tiles representing negative 7. And we again, so that will be 7 plus negative 7. But now we know that a yellow tile and an orange yellow, okay, an orange tile makes a or make a 0 pairs. So how many 0 pairs are we going to make here? Okay, so as we make the 0 pair, we are actually taking away the yellow square tiles. So we remember we have originally 7 yellow tiles there, but now as we make the 0 pairs, we took away the 7 yellow squares. So we have 7 minus, or 7 take away 7, or 7 minus 7. Okay, so 7 plus negative 7 is 7 minus 7. Okay, so applying what we have learned from the first two examples. So if we have 10 plus negative 11, that would simply be 10, then minus 11. Okay, so in summary, if we're adding a negative number, it's just equivalent to subtracting the opposite of that number from the first number. So in this case, our subtrahend are all negatives. Okay, so we have 5 minus negative 4, 7 minus negative 7, and 10 minus negative 11. So using the algebra tiles, we are going to find out what these expressions will be equivalent to. So let's start with 5 minus negative 4. So I have here 5 yellow tiles representing positive 5. And we need to take away negative 4. But we do not have orange tiles. So that means we need to bring in 4 0 pairs. Okay, so we have here the 4 0 pairs, and from there we already have now the 4 negative tiles to represent negative 4. So we can now take away the negative 4. We have 2 rows or 2 sets of squares. All of them are yellow. So we have the first set of yellow squares. There are 5, and this represents positive 5. The second set has 4 squares, and this set represents positive 4. So 5 minus negative 4 is equivalent to 5 plus 4. Okay, so what do we have here? We see that subtracting negative 4 from 5 gives us, instead of subtracting 4, we see that we are adding the opposite of negative 4, which is positive 4. So let's see if it works with 7 minus negative 7. So 7 minus negative 7. So the first number is still, or first addend is still 7. And then instead of the minus sign, that becomes addition. And we take the opposite of negative 7, which is positive 7. Here the 7 0 pairs again. These 7 0 pairs do not change the value of the original representation because the value of each pair is just equal to 0. So we have here 7 yellow tiles, and then we have 7 orange tiles with their corresponding pair of yellow tile. So now we can take away negative 7 by taking away the orange tiles. So what we have now are 2 sets of yellow tiles. One set, the first set is the original 7 yellow tiles, so that is positive 7. The second set, it consists of 7 yellow tiles that we got from the 0 pairs. So this representation shows 7, positive 7 plus positive 7, or 7 plus 7. Okay, so we have verified that 7 minus negative 7 is equivalent to 7 plus 7. So remember, if you're subtracting a negative number from any number, it's just the same as adding the opposite of that number to the first number, or the minuend. Okay, so let's apply what we have learned there from to this last numerical expression. So if we have 10 minus negative 11, then that is equivalent to 10 plus 11. Okay. Okay. The last set of numerical expression involves subtracting a positive number from a negative number. So like negative 5 minus 4. So using the algebra tiles, we have here 5 orange square tiles to represent negative 5. And because we want to take away 4, we do not have yellow tiles here. So we need to bring in 0 pairs. Okay, so we have the 4 pairs. So we can now take away the positive 4. That leaves 2 rows of squares. All of them are orange. So first row has 5 orange squares, and that represents negative 5. And then plus the second set, we have 4 orange squares that represent negative 4. So negative 5 minus 4 is equivalent to negative 5 plus negative 4. So what do we have here? Negative 5 minus 4. So we can see that the first number is just simply added to the opposite of positive 4, which is negative 4. So we have for negative 7 minus 7, this will be equal to negative 7 plus negative 7. Okay, so we have 7 orange tiles to represent negative 7, and because we want to take away positive 7, so we need to bring in 7 yellow tiles using 0 pairs, 7 of them. So we have the 7 pairs. Now we can take away 7, the 7 yellow squares, and then let's see what's left. So after removing the 7 yellow squares, we're left with 2 sets of orange squares, and each set has 1, 2, 3, 4, 5, 6, 7. The other set also has 1, 2, 3, 4, 5, 6, 7. So we have 2 sets of 7 orange tiles. So 7 orange tiles represents negative 7, and the second set also represents negative 7. So we have negative 7 plus negative 7. Altogether, we have negative 14. So using what we have learned from the first two examples, then let's apply that to find the equivalent expression for negative 10 minus 11. So the first number will still be negative 10, and then plus the opposite of positive, rather negative, the opposite of positive 11, which is negative 11. So you have seen the 3 cases of expressions that involve negative signs. First one is when you're adding a negative number. It results to just subtracting the opposite of that negative number from the first addend. And then if you're subtracting a negative number from another number, it's just simply equivalent to adding the minuend here by the opposite of the negative number that you are subtracting. And lastly, if you are subtracting a positive number from a negative number, it will just be this equivalent to adding the opposite of that positive number, which is the negative. Okay, so hope you have learned something from this presentation, and watch for my second video, which will be about simplifying negative signs in algebra expressions with variables. Thank you so much, and have a good evening.